Okay, this video is to introduce propositional analysis. It's chapter 3 out of our textbook, and let's get to it. Okay, so we're going to talk about the logical properties of sentences and the logical properties between sentences. Let me tell you what those are, just to name them. So individual sentences can have properties. For example, they can be valid or contingent or unsatisfiable. And then there can be properties between sentences. For example, one set of sentences can entail another sentence or set of sentences. One sentence can be equivalent or logically equivalent to another sentence. So there's a relationship between two sentences, two or more sentences actually. And a sentence can be consistent with another sentence. So we have here a bunch of or several relationships between sentences or sets of sentences, and we have properties of individual logic sentences. And this chapter we're going to talk about the relationship between those. So let's first talk about properties of individual sentences. Okay, so what is a valid sentence? A sentence is valid if and only if it is satisfied for every truth assignment. At first, when we start talking about this, it might seem trivial. So let me give you an example. And I think this would be the simplest example. And so here's a sentence, phi 1. And the sentence is the disjunction of P and not P. It's P or not P. Here I've made a truth table for P or not P. It's a really simple truth table. And notice that the sentence P or not P is always true. What I mean by that is satisfied by every truth assignment for P. There's only two truth assignments, true or false, but every one of them leads to P or not P being true. That might seem trivial, but phi 1 is satisfied for all truth assignments of P. That means phi 1 is a valid sentence. Okay, you might be thinking to yourself, why are you talking about this trivial sentence? Like, this sentence literally says something like, it is raining or it is not raining. And that's true in all cases. So you might be thinking, okay, so let's go look at another example. Here I have phi 2, which is R implies P or not P. Okay, here's the truth table for that sentence. Notice that over here in the final column is my sentence, and I use these columns to help build the truth table for that. You have to remember now, going back to what we talked about in a previous video, the truth table for an implication. And remember that this sentence is an implication. The consequent of the implication is, in this case, a valid sentence, which means that it's satisfied by all truth values. Or another way to say that is, the consequent is always true. If you go back and look when we first were talking about compound sentences, if an implication's consequent is true, then the implication is true. So this consequent is always true, which means the implication is always satisfied. And you can see, here's the truth table, it's always true. So there's another example, not quite as trivial of an example, but related, of a sentence. All the truth assignments of P and R will satisfy phi 2. That makes phi 2 a valid sentence. Okay, even if you are thinking that was somewhat trivial, I want you to start, I'm suggesting that you start encouraging your students to think metacognitively about valid sentences. Like, encourage them to think about their understanding, or how would one go about thinking about this. So here's a third example. It's related to example 2, so phi 3. And I want them to start, kind of putting down their understandings. So we already know an implication is always satisfied if the consequent is satisfied. That means if the consequent is true, the implication is true, regardless of what the antecedent is, true or false. Here, phi 3, the consequent is a valid sentence, which means that it's satisfied by all truth assignments. And psi can be any logic sentence with any truth value. It doesn't matter. Therefore, phi 3 is a valid sentence because as long as the consequent is true, and we know that the consequent is a valid sentence, it means it's always true, then phi 3 itself is always true. Since psi can be any logic sentence, there are infinite number of valid sentences, like phi 3, I mean. Okay, so I haven't rigorously proved this, but I could, using induction. We'll talk about that in a later chapter. But this is the kind of thinking, the stepwise kind of thinking students should start to do at some point. I'll leave this up to you to decide what stage your students are. This could be an advanced piece of work for students who don't find challenge in the more, the simpler or more straightforward problems, and this could be something that would challenge them. But I think that all students eventually should be able to get to this level. Let me give you my fourth example, the one that probably has the highest meta level of thinking going on, I think, for now anyway. So let's start off by setting up a proposition vocabulary like we've done in the past. I will use just 3 proposition constants, P, Q, and R. And in this case, P stands for the antecedent of an implication is unsatisfiable. And Q is the consequent of an implication is valid. And R is the implication is valid. Okay, what I'm proposing as a sentence, a logic sentence, is this implication where the antecedent is a disjunction. And if I were to read this and kind of translate this, I think it says, if the antecedent of the implication is unsatisfiable or the consequent of the implication is valid, then the implication is valid. If you think about that, and the way we talked about implications and the implication truth table, then that should become obvious to you. Okay, so I've written down a sentence, a logic sentence right here, that sort of captures this thinking right here. All right. Not necessarily thinking that that's the most important thing to know, but it is an important thing to know. And more importantly, if students can start to do this, then it's showing that they're starting to think about their understanding in deeper ways. Like there's no longer surface thought going on here. Okay, so what's an unsatisfiable sentence? A sentence is unsatisfiable if and only if it is not satisfied by any truth assignment. Like if it can never be true. That's what we mean when we say that. So here's an example. Again, the simplest example. This is right out of the book. Phi 1 is P and not P. So if P is true, then not P is false. And the only way the conjunction can be true is if they're both true. And conversely, if P is false, then not P is true, and the conjunction is false. So this conjunction, this sentence, phi 1, is always false. That means there is no truth assignment for P that can satisfy it. And that's what we mean when we say phi 1 is an unsatisfiable sentence. Here's another example. This is not quite as trivial as the first example. So here I have an implication. And notice that the consequent of the implication is the conjunction that I just used as an example. We already know that's unsatisfiable. So this will always be false, regardless of the value of P. And this is the disjunction that we talked about in the valid sentence example. And we know that that's always true because this is a valid sentence. So thinking about what we know about implications, an implication is false when the antecedent is true, but the consequent is false. And this antecedent is always true, and this consequent is always false. So what does that mean? Phi 2 must always be false. Or another way to say that is, phi 2 is not satisfied by any truth assignment of P. And that means it's an unsatisfiable sentence. Okay, so you might be thinking, this one seems trivial, this one's a little less trivial, but maybe when you think about it or make the truth table, it seems a little more obvious. So let's start thinking about it some more. Again, I have taken example 4 and complicated it somewhat. We still have as the consequent an unsatisfiable sentence. Remember, that will never be true. But as our antecedent, we have an implication now. The implication is the antecedent of this implication here. And we already decided in our previous examples that this is a valid sentence regardless of the value of psi. Okay, so go through very similar kind of thinking that I did in the previous example. The antecedent of phi 3 is a valid sentence. We already talked about that. The consequent of phi 3 is an unsatisfiable sentence. We talked about that. Psi can be any logic sentence with any truth value. It doesn't matter what it is. And an implication is unsatisfiable if the antecedent is valid and the consequent is unsatisfiable. Since psi can be any logic sentence, then there's an infinite number of unsatisfiable sentences like phi 3. Okay, you might think about using this kind of thinking, and the way you might do it is to give students an assignment to try to find all the unsatisfiable sentences that exist. Obviously they can't do that, and when students start to realize that it can't be done, then they need to be able to prove that it can't be done. Alright, so again, I'll use my strategy that I've used in the past. Here I will define my proposition vocabulary. P is the antecedent of an implication is valid. Q is the consequent of the implication is unsatisfiable. And R is the implication is unsatisfiable. And so here we have a logic sentence. And I think what this says is, if the antecedent of the implication is valid and the consequent of the implication is unsatisfiable, then the implication itself is unsatisfiable. That's what it says. And that tries to capture the kind of thinking that we're doing here. Again, if you can, as students start to transition into what I'm going to call this meta-thinking level, where you're thinking about logic on a higher plane, not down and dirty just trying to figure out truth tables or trying to figure out if a sentence is valid or not valid. Here you're thinking about whole classes of sentences. That's an interesting transition. All right. Oh, a contingent sentence is contingent if and only if there's at least one truth assignment that satisfies and at least one truth assignment that falsifies. So contingent sentences are the kinds of sentences that we were first introduced to. For example, the conjunction. There are some cases where it's true, here case 1, and some cases where it's false, here cases 2 through 4. So because there are some truth assignments that satisfy and some truth assignments that falsify, this is called a contingent sentence. At first we might be tempted to say, well, most sentences are contingent. But that's not really true, because we just proved that unsatisfiable sentences are infinite. Okay, so let's talk about then satisfiable and falsifiable sentences. So a satisfiable sentence is satisfiable if and only if it's either valid or contingent. And what that means is there's at least one truth assignment that satisfies the sentence. So a falsifiable sentence is a sentence, it's falsifiable if and only if it's either unsatisfiable or contingent. And that means there's at least one truth assignment that falsifies the sentence. So let's get a graphical look at this. So there's satisfiable sentences, there's falsifiable sentences. Satisfiable is made up of valid and contingent sentences, and falsifiable is made up of unsatisfiable and contingent sentences. So contingent sentences might be made, are both satisfiable and falsifiable. That's what they are. So what are the usefulness of these types of sentences? You know, as we go through this, I think I've try to encourage my students to think, well, what does that mean? What kind of sentences might those be? Or why would I be interested in those kinds of sentences? That's the kind of thinking we want them to do. So valid sentences, well, what do they tell us? They're satisfied by every truth assignment, so they don't rule any of the possible worlds out. Remember what we did when we were using carnivore world or sorority world? We were trying to rule out some worlds of our 50-something thousand worlds, and we narrowed it down to 4 worlds. So we used sentences that were contingent to rule out some of those. But here, valid sentences, they're always true, so they don't rule anything out. These are the kind of sentences that you might say to somebody like, you know, it will rain tomorrow or it won't. Or the business will go bankrupt or it won't. Those sentences don't really provide us much information because although they are true sentences, they are kind of unsatisfying. I mean, they give us no satisfaction in the sense that they don't help us to rule out any possible outcome worlds. Unsatisfiable sentences, what do they tell us? Well, they're satisfied by no truth assignments, so they rule out all the possible worlds. They kind of like obliterate any outcome worlds. So you might be thinking contingent sentences are where it's at. In some sense, they are the sentences that we are most interested in because they help us to rule out some worlds while allowing other worlds. So in a sense, that's what we're looking for. But I think, well, not think, but in the next few chapters, you're going to find out that we'll have a use for valid and unsatisfiable sentences. They will help us to perform some legal transformations on logic sentences, and they will often help us to interpret or expand our understanding of logic.